All right, so the next part I'm going to draw is I'm going to try to go, so I've done a tank and a top and a bottom handle and a valve, and then I'm going to try to just go with big pieces, going through the hose process and then down through the gauge and some little attachment pieces like rivets and zip ties and things like that. The next piece I'm going to draw is the nozzle right here. And if you look at this, you can see that it's tapered, and there is a little bit of a flange on the top of it. If I scroll, see if I can find the picture right under here, which is called the ferrule. It's the thing that crimps the hose onto a fitting here for the nozzle to plug into. There's sort of a flat disc where it stops and blocks the end of the hose, which is kind of hard to see in this picture. But you can see it's tapered. The wall thickness, meaning the thickness of the material, is 1/8 of an inch all the way along. And if you look really carefully right here where my cursor is, you can see that it has a flat on this side and on this side. So making that flat is the last process. Really, this whole thing is this is a situation where you have to actually use loft instead of the typical extrude. So at any rate, I've gone and pasted my dimensions on here. And if you look, the way to get the wall thickness, where it says up here 0.125 wall thickness, is literally just to go ahead and draw do an offset. Okay. I thought I had a layer for the nozzle, and I sure don't. So I'm going to start by just going ahead and making a new layer, and I'm going to call it nozzle. And we can make it whatever color we want. So I'll make it something that'll contrast the hose, because that will be one of the next parts I make. Okay, so that's that. Go to my nozzle layer, and there it is. All right, so I'm going to start on the flange end of this. And it tells me right here that there is an outside diameter. This is down at the nozzle portion of 0.436 inches. So I'll just draw a circle, and I'll draw a nozzle, and I'll say diameter 0.436. And that's what we measured on. That should be, it says that it is the OD, or the outside diameter. So now if I offset 0.125, this is the inside diameter, meaning that's where the stuff inside the fire extinguisher would shoot through. Now on this one, on the other end, I have an outside diameter of 0.625. So I'll go diameter 0.625, easy enough. And then the same offset works just fine. Offset 0.125. Oops, I think I went out. It has to go in. Okay. So, piece of cake. Next thing, I'm going to go here, and I'm going to see a length of 3.563. So in order to get that, I'm just going to draw a line from the short end to the big end, which is 3.563. Okay, so now I'm pretty well set up. Before I do that, if what you can understand, or hopefully understand, is that the outside diameter of the little flange piece that butts up to this ferrule is the same as the outside diameter of the large end of the nozzle. And then the inside diameter of that has to be the same as the inside diameter at the short end of the nozzle. And since I've drawn both of those things, that's real easy. So for that one, I just take the small inside diameter piece, and I copy it. And then I take the large outside diameter, and I copy that. And for some reason, my center is not picking up, but it is selected. I don't know why it won't pick up, but we'll just go from here, and we'll grab that here in a minute. I've had that issue a few times where center, for whatever reason, won't pick up. Let's see, were my object snaps even on? Oh, that might help. So my object snaps were not on in that case. So now I can move it from center to center. Okay. Take your short end and move it from its center point to the center of the line that you drew, and then move
Someone for custodial call 7273, please.
and then move this point over here, and you're all set up for actually now modifying this in 3D. Okay. It tells us, so what I'll start with right here, on the flange end of it that butts up to the hose, it's 0.050 in thickness. So this right here constitutes the flange end, and I do need to remember that. Okay. So I'll go to my Southwest isometric. My hope here is I can get this done in one video. So in order to do this now, I just have to extrude this 0.050, and that will end up making my flange. That part can be, oops, try this again, extrude this 0.050, and then just do a subtraction to get the guts out of there. Okay, so that'll be my flange. It's going to go in this orient. Everything travels along this line. So right off the bat, I can do a 3D rotate 90 degrees. And then to start this process, I also have to do a 3D rotate 90 degrees. And then I have to do this, a 3D rotate 90 degrees. A student asked me in class the other day, why do I draw everything flat on the ground rather than just, in this case, since the circles were already laying flat on the floor, I could have just drawn this vertical line upwards. And the answer to that is no reason. It's probably just the way that I think about it. So that's that. Okay, so now both of these circles have to travel down this pathway from here to here, but it's tapered. This circle is smaller than this circle. So extrude won't work. If I went ahead and extruded this, you can see it's not going to go ahead and be able to get to this diameter. So what I have to do is loft, okay? And rather than do that, I'm going to go back to my nozzle layer. So when it does it, it'll stay on the right layer. Come under extrude, hit the drop down, go to loft. Easy tool to use. It's asking you to check these sections in order. Well, section meaning the section here, and then the section here. And you always want to work from inside out, because if you look, what's going to happen, if I were to loft from here to here, it creates that tapered, it's a cone, really, a truncated cone. Truncated meaning it's cut off on the pointy end, but I'll bury the inside portion, and I won't be able to subtract it out. So what I have to do is grab the inside portion first, no right clicks here, grab the second portion, you have to right click enter, or hit the space bar twice or hit enter twice. I'll do it one more time. I'll go loft here, loft here, right click enter, and now you can see I have a truncated cone within a truncated cone. So I should be able to just subtract, click the outside, right click the inside, right click, and now I have this portion, which is the tapered tube. If I go back to the drawing, the overall length from the outside of the flange, meaning this face, this outside of the flange, to the other end was 3.563. So now when I move this, I'll have two endpoints, or two center points. I have an inside center point and an outside center point. So I have to grab this from the outside center point and place it on the other center point or the stick, which is a little bit unrealistic, right, in terms of construction, because it's like putting solid on solid, but it also sort of doesn't matter in this case, because this is, again, just a rendition of something, okay? If I look down here, there's nothing covering, and I can see the taper on the inside. So this is part one. When you're finished with it, you do want to come up, you want to click Solid Union, and select both of those, right click, and now you can see Solid Union is like a 3D join. So that part's done. All I have to do is use slice to nail these flats, and I'm going to make that a second video.